Hi guys, this is the fourth lecture or fourth problem of the DSA series. So let's get started. Okay, so it says given an array of strings strs, group the anagrams together. You can return the answer in any order. Okay, so first and foremost, what is an anagram? Let's say there is this word eat, and its anagram can be ATE. ATE. Okay, so anagram is nothing but if we can form a word by rearranging the letters, then that is an anagram, right? So this is an anagram of this, then this is an anagram as well, because these all three contains the same letters just rearranged in different way. That's all. So this is what an anagram is. Now what our problem says is given an array of strings, we have to return the group of anagrams. So this group contains three anagrams, this group contains two anagrams, and since BAT doesn't have any anagram in here, we will return it separately as a single substring. Okay, as a single subarray in this array. Okay, so I hope it is clear what we need to return. So yeah, let's get started. Let's write a function. What is group anagrams? Get grouped anagrams. Okay, spelling is correct. It will have an array of strings. Now let me just do it, and I'll make you understand on the way and after doing it as well. Okay, so let's map over. Also I want you to make an effort to understand it as we solve it here, right? For let str of strs, we are mapping over this. Then we can have an object here, and then here what we can do is, okay, we can sort these strings, individual string that is present in the array. We can say const sorted str is equals to str dot. We cannot sort it directly, we have to first split it, sort it, then join it, right? Split dot sort that join. So why I am sorting this, so that all the strings are, so this NAT, so let's take this example. So these NAT and TAN, so if we sort it, we'll get ATN for both the cases, right? Here also we get A LMNOPQRST. Okay, so ANT we'll get ANT. For this we'll get ANT, for this we'll get ANT. So we can have an object, and in that object we can have ANT as key, and as value we can have an array which makes this word ANT, which is this TAN, and what else, NAT, right? But this ANT will be same, right? And so you got my point, right? Again, for EAT we can have AET, for this we'll have AET, for this we'll have AET, and for this we'll have AET, right? So we will have, again we can have another key AET, and its value can be an array of anagrams which makes up this AET, right? So that is what I intend to do with this object. So yeah, here we have sorted the string. Now we can check if sorted a string, let me just comment this out. If sorted a string, nope, if obj dot sorted a string exists, then no. If it doesn't exist, then if it doesn't exist, that means we have encountered this word ANT for the very first time. Doesn't exist, then have an empty array being initialized, right? And if it exists or it doesn't exist, doesn't matter. If it doesn't exist, we already have an empty array. If it exists, we already will have something in this. Maybe we already have TA in this, right? If it exists, then we can simply not equals to, can simply push str here. So yeah, this way we'll get this kind of object which contains the sorted key, which will be same every time. So we can access it in the object for every time we encounter the anagram of the same word, and that word can be stored in here. So this way we can do it, and then we can simply return object dot values obj. So it will return an array of these values. Yeah, now let's see if it's working. I'm not sure if I've started the recording. Yeah, I started. Okay, so let's check it out. Let's give it let input is equals to this. Now give it the input and see what we get in the console. Node 004 group anagrams subgroup anagrams.js. Okay, so we get 3 groups of anagrams, right? One group, second group, third group. So yeah, it's working. Now let's come to its time complexity. So here we have time complexity of O of n, since we are mapping over these strings, these strings, if they have length n, and then we have this as well. So this we are doing for each and every word that is in the string. So this has the time complexity of into and we already used k log. Let's use k log k. Okay, yeah. So it has the time complexity of n log n. So here we write k log k because k is the length of the individual string that is being present in the array, and this is the array length. Yeah, so this is the time complexity. Now this way is good enough. Like if this question is being asked in an interview, this way is like you can write this, you can show this method. This is good enough. There is another way which I can show you, which has slightly lower time complexity, that is O of n into k. Although that will be little complex, so I recommend you to stick with this if asked in an interview or in any setting. But let me show you this way as well. But I'll want you to stick with this. You can tell interviewer if he wants that there is another way, but that way is little bit harder to explain, and there is not much gain. So yeah, but still I'll show you. Let's say get grouped anagrams 1. Okay, strs. So I'll also write here recommended way. Okay, since I gotta push this, now I'll show you another way which has the time complexity of O of n into k. Okay, so this is the one, strs. Now here what we can do is so this is okay, yeah, this way is possible. So this way is only possible because here it says the stri consists of lowercase English letters, that is these will always be lowercase English letters right? These strings will be made up of lowercase English letters only. Okay, that is why this another way is possible as well. Here what we'll do is we'll again map over the string, but we won't do this. We won't like have sorted string this way. We'll have another way. So let me just do it, and while I'm doing it, you try to understand. If not, I'll try to explain while I'm doing it, as well as after I'll done doing this another way. So we can do here. Okay, so for let str of strs, let's map over it, and now we can have, we can have an let's have an object here. So yeah, we have const here as well. So yeah, const will work. We don't need to use let here as well. So const obj, and then we can have, let's say, an array new array. We can have an array of 26 elements, because there are 26 characters in English alphabet, and then we can fill each one with 0, right? Okay, now we can map over letter or let car character of str each string. Let me first do it and then I'll explain. Okay, I don't want to lose focus while doing it. Let car of string, and then we can say const a equals to car dot what's that thing where we know the ASCII value of the car code at, it doesn't show me anything. Car code at yeah, it returns Unicode. Okay, car code at 0. Yeah, car code at 0 will know that, and we know that ASCII value of the this no of a in small case is 97. So we'll subtract 97 from here. Instead of having it as a, we can simply do so a is at 0, now b's ASCII value is 1, c is 2, and so on, right, till z. Okay, d is 4, and so on. So now what we can do is we can have this arr, and at a, you understood that for arr all there are, say, 26 elements, all are 0, right? However, at this place we can have plus plus, so whatever the value is we can increment it, right? Now we can have const key is equals to car of string. Okay, arr dot join, we can join it using hash. Okay, or like we can have anything here. I'll explain you in a bit, just bear with me. Let equals to arr dot join. Now that car of string Okay, we have the key. Now we can have this, we can have obj, again we can say simply do this like which we did above, obj key. If this doesn't exist, then simply do, and don't go away, bear with me, I'll explain you in a bit what I am doing. So just first let me do it. Right, obj key, if it doesn't exist, do this. If it does exist, then simply okay, dot push str, and now return same thing, obj object dot values. Yep, object dot values. Okay, now let me first see if it's actually working, right? And then if it's working, then I'll explain you what we just did here. Get group anagrams 1. Okay, yep, it seems to be working, and this has the time complexity of, again, O of n into k, n into k. Okay, let me explain it to you. So what happens is, let's say there are two anagrams. Again, my name is Rajat, so Rajat is in Rajat, and then TAARJ, right? These two are anagrams, right? Now let's say this is okay. So for this, if we map over the, if we see the English characters, what we can do is, for a, like initially you know that this, we have this array of 26 characters, like of 26 elements, since there are 26 characters in English alphabet, and all are 0 0 0 0 0 0, right? This is what we have right now. And if we like encounter a, it will first convert it to 1, because first day, then on second day it will say add 1 again, so now it will be 2 again, then it will remain 0, it will remain 0, unless we have this t. If we got t, it will convert it into 1, right? And then, so this is what we are doing here, right? So if so we are, so for each individual string, we are mapping out of each string, and then we are having an array of 26 elements with each element being 0, and then we are mapping over this string. For this string, we are seeing this array. So if let's say it has a, increment a. If it doesn't have b, let it be 0. It doesn't have c, let it be 0. Doesn't have d, let it be 0, and so on. Then it has t, make it like add 1. So here we are adding 1 like that. We are doing that for, so we can do it like, we don't have to map, like we can simply have that index and add 1, like, right? This is what we are doing here, and then we are joining it using hash. Okay, so there can be the case where we don't have to actually use hash, but we are joining it using hash, because let's say we have, like, okay, so we have 0 here. So if we join this without hash, we'll have like 200 something, right? And let's say a came 20 times, then again we'll have 20 here, like 20 here, then 0 0. So to avoid this confusion, we'll have hash in between, so we understand, okay, these are different keys. Okay, so yeah, so we join it using keys, and then we have this unique object then, right? For this object, if that particular key is present, it's the same logic as we have here. Just think and you'll understand. If that key is present, then awesome. If it's not, then have it value as an empty object. Here the key will be very long. It will be like 26 characters long key with hashes in between, right? So the key will be like 0 0, maybe hash 1 hash 2 hash 1 hash 0, and things like that. It will be like 26 characters long with hashes in between. So key, if it's not present, have its value as an empty array. If it's present, then simply push the string, right? Either way, we'll push the string in line number 63, because if it's not, we already initialized it in line number 61. So yeah, in this way we'll again get the anagrams being grouped together in values of this object, and then we can finally turn this. So yeah, this is also a way to do it, and it has the time complexity of n into k. Why n into k? Because n, because of this, because we are mapping over the string, k because we are mapping over this, right? Yeah, that's the only thing. So yeah, it has the time complexity of n into k. Now let me just remove this, and let me write a is equals to 97 in ASCII. Okay, so that's all from my side, and I'll repeat one more time. This is the recommended way, but yeah, it's good to know this as well. Yeah, let me push this so that you guys can have the code. 004 group anagrams. Okay, I'll give the link in description. And yeah, it's fun solving DSA, man. Let's meet tomorrow.